To the last section of chapter 2, solving absolute value inequalities. How can you solve an absolute value inequality? And the answer is, it turns out, very similarly to solving an absolute value equation, which is making two equations, or in this case inequalities, and then going from there. This is page 53 of your student journal. Let's get the ball rolling. So this is saying essentially the same thing as solving absolute value equations, which is a reminder that the C on the right side of the inequality must be greater than 0, as in must be positive, because if it is negative, then you are not really worried about it. If an absolute value expression will never come out to be negative, so then you would just say no solutions. Very simple. On the other hand, if it's asking you for something positive, then you could just go all solutions. So here we have y plus 2 is less than 8. So we're going to go ahead and say y plus 2 is less than 8. And you know what? I'm actually going to go back up and re-examine this for you. I know I knew I skipped something. So when you say that, if the original expression is less than C, then you do less than C, but you also have a negative version, but the negative version is when you swap the sign. Same here, if the original is greater than, then you keep it that way, but then when you make it negative, then you also have to swap the sign. So how does that apply for number 1? Well, y plus 2 is less than 8, but y plus 2 is going to be compared to negative 8, but because I had to swap the sign on that, then I'll also have to swap the symbol. So you subtract 2, you get y is less than 6, and you get y, subtract 2, y is greater than negative 10. What will that look like? Negative 10 is less than y is less than 6, right? Y is less than 6, boom. Y is greater than negative 10 is less than y. Those are the same thing. And I just combine it into one. This is a compound inequality. So I'll just have my negative 10, negative 8, negative 6, negative 4, negative 2, 0, 2, 4, 6, 8. No equal signs, so none of these circles are going to be filled. They will just be like that. 10, 6. Pretend that's actually on the 10. And we have this line right here. That's it. Okay. That's the gist of it. If you could solve absolute value equations, then this is truly not far off. So you have q over 3 greater than positive 2, q over 3, we're going to swap the sign and the symbol. So swap the sign to be less than, and 2 turns into a negative 2. You multiply both sides by 3. I'm not going to show you how to draw the number lines, because the previous videos have practice on that, so you can just refer to those. Q is greater than 6, multiply by 3. We are not multiplying by a negative number, so nothing has to switch, as a reminder. Even though that negative 2 is a negative number, it's not the number that we're multiplying by. We're multiplying by 3. So negative 6 and greater than 6. So we have q is greater than 6, q is less than negative 6. These are going to be going off in opposite directions. Oops. Sorry, I skipped that page. Let's go to number 3. Before we can solve anything, we got to get rid of all this extra stuff. We just want the absolute value expression on one side. So subtract 10, 3 times absolute value 2a plus 5. I said 3 times. How are we going to cancel out times or multiplication? That's right, division. So we're going to divide both sides by 3. Voila. You will have 2a That's the absolute value side. The absolute value of 2a plus 5 is less than or equal to 9. So I'm going to show you how to set up the 2, but again, they're solved just like 1 and 2, so I'm really not going to bother. Let's see, 2a plus 5 is going to be equal to or less than positive 9, which is fair. And then when I switch the symbol to turn it into a negative 9, I will also have to switch the sign. So instead of a less than, it will be greater than. On both of these, you will subtract by 5 and then divide by 2. Moving on into the next problem, number 4. Y minus 3 less than equal to 4. Y minus 3 greater than or equal to. If I switch the sign, I also have to change the positivity or negativity of the right side. So you add 3 on both sides, plus 3, plus 3, plus 3, plus 3. So I'm going to get y is less than equal to 1, and y is greater than equal to negative 1. So if it's less than 1 and it's greater than negative 1, that means between them, right? So if it's between them, we would put the lesser number at the end, or the least number at the end, y in the middle, and then the greater number on the right side. They both have equal signs. Okay, we can move on from that. At first take, I would say that, oh, less than 0, well, less than 0 is a negative number. We don't have to worry about that because absolute values will never be negative. There are no solutions. But before you think about that, you have to simplify this, or you have to get the absolute value expression by itself. So I'm going to add 4 on both sides. 3 plus r less than 4. So now our two expressions are, I'm just going to type it out. I'll add the symbols later. 3 plus r, less than 4, and then 3 plus r greater than negative 4. Sorry, there are no symbols to add. That's it. 3 plus r is less than 4, and 3 plus r is greater than negative 4. We're going to subtract 3. 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 So yeah, r is less than 1, and r is greater than negative 7. So I'll say r goes in the middle. What is below r? What is r greater than? Negative 7. An easy way to tell if you wrote this correctly or not is to just look at the left and right sides and compare them. The negative 7, ignore that r, negative 7 less than 1. If that's true, you wrote it right. If it's not true, you wrote it wrong. As an example, I could also write it the other way around. 1 is greater than r is greater than negative 7. If I ignore the r and just say 1 is greater than negative 7, that's true, so I still wrote it right. Just a little demo for you guys on the structure of this compound inequality. Okay, moving on. Okay, negative number. How often is an absolute value going to be greater than a negative number? Always. So you could say, if it's always, that means there's a never-ending number of solutions. Infinitely many solutions. As far as what that might look like on a number line, you could honestly just go like this. 0, 1, negative 1. All solutions, right? All numbers are solutions. And you make your line like that, except you would make it, on the actual number line. You go, and it goes on forever. 2, 3, 4, 5, 6, 7, all the way to positive infinity. To the left, all the way to negative infinity. This one, number 7. When will there's nothing the absolute value expression does not need to be isolated. It is already isolated. There's nothing left on the left side. So there's nothing for me to add or subtract or multiply to make this not negative. And the same goes here. When is it ever going to be less than a negative number? Well, it's an absolute value. It's never. You say no solutions or no solution. Capiche? The reason why this does not work is because an absolute value, all this in here, will never be less than a negative number. It will never be a negative number. So it will never even be less than 0. And in this case, it will always be greater than a negative number. It will always be at least equal to or greater than 0. So we're not worried about this. Okay. I had a few more problems. 8. So again, we have to isolate the absolute value expression. Create that border real quick, left and right. Minus 8, minus 8. So we got 17 minus 8, I do believe is 9. So we have 4x minus 7 greater than or equal to 9. And I'm just going to type out the resulting inequalities that you should come up with. So again, one that is normal is the, don't forget the greater than or equal to. I cannot type it out, but I will add the dash soon. And the other one, you change the symbol and you also change the sign. So 4x minus 7 is greater than 9 and greater than or equal to, and 4x minus 7 is less than or equal to negative 9. I'll let you guys solve that on your own. It looks a little complicated, but really you're just adding 7 and dividing by 4. So that's all there is to it. For this one, minus 14, minus 14. Again, we're trying to isolate the absolute value part of the expression. So that's 6 times 3 minus k is greater than 14 minus 14 is 0. So at this point, the only answer that will not work is, oh well, you know, I'll show you anyways. So divide everything by 6. So divide everything by 6. Three minus k greater than 0. If you work this out, you know, I could just add k to both sides. Nothing plus k is k. So 3 must be greater than k. There is no negative form, is there? Let's see. Negative 0. Yeah, it's just going to, negative 0 is the same thing as positive 0, right? So again, we got 3 is greater than k, or that's another way of saying k is less than 3. But if you pause and consider this real genuinely for a second, 6 times something has to be greater than 0. And you know that this something has to be positive, right? So as long as it's not 0, means that k cannot equal 3. However, if you think about anything else, like 4, 5, 6, or 2, 1, 0, then those will result in numbers that you can multiply by 6 and still be greater than 0. So even though we have this case greater than 3, it also, in fact, is, how can I write this? K must also be less than 3. And what that will look like is 3 empty, boom, and the other side as well. Boom. Okay, so that's that problem, and we can move on to the last of the student journal. At a certain company, the average starting salary S for a new worker is $25,000, the actual salary has an absolute deviation of at most 1,800. Write and solve an inequality to find the range of the starting salaries. So let's see. The average starting salary is 25,000. Deviation has to be less than 1,800. So you could say S minus deviation. Deviation just means to deviate is to be different from something, and I guess if you think about difference, that means subtraction. So S minus 25,000. This is absolute, which means that it doesn't matter whether it's positive or negative or whether it's above or below 25,000. It just matters that it has to be at most, which means less than or equal to 1,800. So if you think about this, if you look at this, if I have 26,800, that still falls in the range. But I can't just be 1,800 ahead of 2,500 or 25,000. I could also be 1,800 below 25,000, which is what, 23,200. So what that will look like is solve right. So I wrote it. I'll solve it. I'm gonna type it out for you, but you will solve it. S minus 25,000 less than or equal to. I will write that 1,800. Later on, S minus 25,000 greater than negative 1,800. So this is a minus sign. That will be a minus sign. And I will give you the answer as well. I'll leave you to work it out, but you can check your answer, of course. S should be between, like I said, 23,200. Oops. 23,200 less than S, and at most 26,800. Alright guys, that's it for this chapter. Good luck on your chapter test. If you have any questions, ask your teacher or let me know.